Okay. These are perfect squares, numbers that you can square root right into a whole number. The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, square root of 36 is 6. And the reason why these are the answers is because if you take 7 times itself, it's 49. 8 times itself is 64. 9 times itself is 81. There's a couple other things we need to add to this. Put that the square root of 1 equals 1. Okay, and also, yeah, that's good. Okay, now take out your multiplication table, and on a multiplication table, perfect squares can be found down this row right here. Okay, down this diagonal row, and they're in bold too, so you can see them. Okay, 625 is the final one. It's not the final one, just the final one on our table. Now, see, 25 is 5 times 5. 49 is 7 times 7. Now, there's another thing you need to put. X to the second, we don't know what number x is, but it's x times x. So the x to the second is a perfect square. Okay, now, if you want to tear that off, you can. Now, we need to put this in factored form. Okay, it's not hard to do. It's what's known as difference of perfect squares. Write it down. Difference of perfect squares. The abbreviation for this is DOPS. D-O-P-S. Difference of perfect squares. Now, DOPS, or difference of perfect squares, is not hard to execute. First off, difference means there has to be a subtraction sign, or the second term has to be negative. First term is going to be positive, second term is going to be negative. Okay? If it is, okay. Now, on each side of the minus, you need to write that as its square root. So the square root of 9 is 3. So 9 is 3 times 3. Write that down. 4. Well, 4 is all, see, 9. 3 times 3. 4. 2 times 2. Now, attached to this 4 is an x to the second. Well, x to the second is x times x. So 4x to the second is 2x times 2x. 2 times 2 is 4, and then x times x would be expressed as x to the second. And then 3 times 3 is 9. Okay? Now, here's how you write that. This is positive, this is negative every single time. And you put 2x, 2x, and then 3, 3. So that's how you factor it. See, now if you would FOIL that, 2x times 2x, we're not going to FOIL today, we're going to factor, but 2x times negative 3, positive 3 times 2x, and positive 3 times negative 3, I end up with 4x to the second, and then negative 6x, and then 6x, and then negative 9. So if I go with my slots and combine the like terms, the x second term is 4. The x, negative 6 plus 6 is 0. So since we add those and they add to 0, they do what's called canceling out. And then when you have a 0, that's like you don't even have that slot. And then you have negative 9. So 4x to the second, and then plus negative is expressed as just minus 9. So that's why this goes into here. Now, what we're going to be doing today is putting these into factored form. There are 2 terms. It is a binomial. Okay? From now on, when we see binomials, we are going to look at the GCF. Draw that. And then we are going to make a second box. It doesn't have to be overly large. And we're going to see if what we have is a difference of perfect squares. And you make 2 parentheses with a positive plus and a minus, positive and negative. Always like that. It's always like that. Okay, so GCF, same thing. Do you have x on the end? No, you don't. The final term, this last slot, does not contain an x factor. So we don't put x. Do you have a negative in front? No, we don't. Okay? So no x, no negative. Then 9 and 4. 4 and 9 only appear in row 1. So if the GCF's 1, we're going to skip it because that's dumb just to divide by 1. Now dops, you make sure that the front term, you make sure there's a minus sign. There has to be a minus sign. It cannot be a plus. If you have a plus, you can't do it. Okay, so 9 is a perfect square. That's 3 times 3. And then attached to the 9 is x to the second. Well, that's x times x. So 3x times 3x. Attach x's to the 3's. And then on the other side of the minus, we have 4. That's 2 times 2. So this is a difference of perfect squares. So you put 3x, 3x, 3x goes in front of the operation signs, and then 2, 2. Okay, so you line that up right there. 3x plus 2 times 3x minus 2. Okay, 144x to the second minus 16. Okay, so it's binomial, 2 terms. So GCF. And then the difference of perfect squares, DOPS question mark. This is how all binomials will be factored in this course from here on out. Okay, there's no x on the final term. They do not, x is not common to both. This has an x second, but this doesn't have x. The final term's missing x, so we cannot bring x out. We don't want to bring the negative out because the first term's positive. Then 144 and 16. So here's 16, and 144 is there with it. So 16 is the GCF. Okay, now put that in parentheses and divide by 16. Now 144 divided by 16 is going to be 9. Now I'm not putting an x under the line. So x stays to the second power attached to the 9. The negative 16 divided by 16 is negative 1. Okay, so minus 1. Don't put plus negative. Now, here's what we do at this point. You take your 16, put it there, then cross it off and cross this off, and you see if this is a difference of perfect squares. So when you do the GCF, you're looking at the second parentheses. So we have the minus. 9 is a perfect square. That's 3 times 3. And attached to the 9 is x to the second. Well, that's x times x, so we attach an x factor on each 3. And then here's 1, 1 times 1. Okay, so then I fill this out, okay? This is a perfect square, this is a perfect square, so I put 3x. You don't put 3x here, you put the x's in front, and then the constant 1 times 1 goes behind. So then instead of writing this, you write times 3x plus 1 times 3x minus 1. You're not solving, so don't put x equals x equals. Okay, next problem, x to the second power minus 25. So GCF and DOPS. It's a binomial. Okay, so we are not going to be bringing x out. This has no x. This has no negative. And then 1 and 25 would just be 1, which means we don't do it. So we go from here. I don't care if you draw those arrows. Doesn't really need to happen. Okay, so we have the minus sign. Now, if your x second has a multiplier of 1, you can certainly go 1 times 1 above it, but 1 is really not an important coefficient to have. If the 1's here, we're going to go 1 times 1. But if you have a 1 in front of an x to the second, get rid of it, okay? So x to the second would be x times x. Putting a 1 in front of the x's isn't really important. It's something we need to do. Now, if it's like a 9 and it's 3 times 3, we got to put it. But a 1, 1x, 1x, that's the same as x. Then 25 is 5 times 5. So yeah, obviously, x, 5, 5. If you put 1x, 1x, it's fine, whatever. I'm not going to fight people on it. Okay, negative 4x to the second power plus 100. So again, we see the, so GCF and then we want to see if we have a difference of perfect squares. Question mark. Okay, so do we have x on the end? No. Do you have a negative in front? Yes. Okay, so we have to factor out a negative. So 4 and 100. So here's 4, and there's 100 all the way at the end. So these are 4 is the greatest common factor. Okay, 4 and 100 are both multiples of 4. So you divide by negative 4. So it's going to be 1. We are not putting an x underneath, so the x stays to the power of 2. And then 100 divided by negative 4 is negative 25. So you place your GCF, you got to remember to do that. Now get rid of this, get rid of this. So now when I look at the dots, it's right here, okay, not from the top. This is where we're at now. It's like if you do the GCF on a 3-term and then do the t-table, you're looking here. Well, dots is no different, okay? So you have the minus. You don't need to write 1 times 1 if it's in front of the x. You can just delete that. 1x times 1x is the same as x times x. And then 25, 5 times 5. Okay, so x, 5, 5. So after the negative 4, you go x plus 5 times x minus 5. Now it's factored. Okay, 1x to the second plus 49. So 2 terms, GCF and DOPS, question mark. Okay, there's no x, there's no negative. 1 and 49 would be 1, so that means that's a waste. Now, we don't have a minus sign, so if you don't have a minus sign, you write no, and you don't do anything. You just bring over what you had. Get rid of the 1 off the x second. So it's just x second plus 49. You can't do anything with that. I know that's x times x and 7 times 7, but it's got to be a minus. If it's not a minus, you write no, okay? When you do check for adopts, the binomial has to be separated with a minus sign. It has to be a minus. It cannot be a plus. Now you're like, oh, it's a plus here, so that'll be the answer. No, that's why you got to do the GCF. It's not going to end up being a minus. So GCF and then DOPS. All right, so there's no x, there is a negative, so we're going to factor out the negative, and then 5 and 125, here's 5 and 125, both in the 5th row, so negative 5. Okay, so that's now 1, x to the second, because we're not dividing by x. Positive divided by negative is a negative, so now we can write minus, and then 125 divided by 5 is 25. Because if you see, if you divide positive 125 by negative 5, that's negative 25. So you don't write plus negative, you write minus. Okay, if the second division's a negative, you write minus. Okay, so you bring over your negative 5 GCF. And we do have the minus now. If the x second has a coefficient of 1, you can just delete it. Okay, it has to be a 1. If it's like a 4, you got to go 2, 2. But 1, because we know that's x times x, and then 25 is 5 times 5. Okay, 36x to the second power minus 121. Okay. So GCF and DOPS. So we don't see x on the end. We don't see the negative in the front. Okay. 36 and 121. Now 36 isn't even on here. Now if there was a 36 row, 36 would obviously be in it with 121. What you can simply do to check is take 121 divided by 36. Now, if you get a decimal, that means the 121 would not be in 36 row. Okay, decimal obviously, so that does not work, so it can't be 36. Now we see 36 in 18's row, 121's not there. Okay. 36 is also in 12's row, 121 is not there. 36 is in 9's row, 121 is not there. Okay. 36 is in 6th row, 121 is not there. Okay. 36 is in 4's row. Now it runs out of room, so what you can do is just take 121 divided by 4. Okay. If it runs out of room. Just take the number you're looking for and divide it by the row you're looking. If you get a decimal, it means it can't be in that row. I got a decimal, it can't be 4. Then 2. 2 is easy. 36 is there, but 121 is an odd number. Okay, so basically it's only going to be 1. Okay, so 36, 6 times 6. And then x to the second is xx. And then 121 is 11 times 11. So you can't delete a 36 like you kind of want. So it's 6x, 6x, 11, and 11. So there was no GCF, so I just write the two parentheses, 6x plus 11 times 6x minus 11. Okay, x to the second minus 7, so it's a binomial again. Okay, so we do have a minus. You don't need, the 1's the GCF. You don't have an x, you don't have a negative. 1 and 7's 1, so we're not going to do it. Now the minus is there. If the x second has a coefficient of 1, get rid of it. X to the second's x times x. But you see 7 is not a perfect square. Okay, you can't write that as an integer times itself. So you write no, and then you just put the original problem in parentheses.